Okay, hello, ROS Developers. I'm very happy to be here again for the second time with the third episode of this series of webinars about how to build a robotics product from the conception idea to the product on the shop in 3 weeks. So let's get started because we have a lot to cover here. And thank you very much for attending, all the people. In case that you have some questions during the webinar, you can ask it. So there on the chat, I'm keeping an eye, okay? So just be reminded that we'll have some delay. Okay, so let's go. Then remember, we are here. Why we are here? Well, the idea is to show you a method that you can reproduce in order to build a robotics product that can be put into the market in a very, very short time. So that is the goal. And the product has to be ready on the market in a record time with just doing as little as possible of development, reusing as much as possible that we have. And it also has to be very easy to maintain. If it is not easy to maintain, then it's also another problem because, well, it will delay us once the product is on the market. Okay, so in this episode number 3, what we are going to see. Remember that we started to watch this episode last week, but we have some problem with the slides. I think everything is completely recovered, so let's go for that. And it should appear here something. Starting to be scared again. Some error. I have an emergency solution in case that this doesn't show. And it's very likely that we are going to have to go to the, oh, there it is. So I don't know, things of Apple. Okay, so in this episode number 3, what we are going to see, we are going to see how to do the testing with the real robot. It's not only one. In the previous episode, we saw how to do the testing on the simulator. Now let's move it to the real robot. How to do it in an optimal way. Then I'm going to show you an iterational process for testing with the real robot in order to test, find errors, catch them, solve the errors, retry again. So let's see how it works. Also, we are going to see how to add the attrezzo to your robot. So it's not only a bunch of wheels of cables and computers and sensors, but it has to have a shape that people like it. And then finally, we are going to go to how to present the product to the public. Okay, so how to do a presentation, basically of your final product. Okay, so let's go. My name is Ricardo Tellez, and I'm the CEO of The Construct. That is a company where we develop tools for learning how to program robots and how to actually program them and test them online. So we provide some very nice courses about ROS, and that make people learn very, very fast. So now that you know what we are going to cover, who I am, and let's go to the part 1. How to do the testing of your programs, of all the things that you have developed in the real robot. Okay, so that's the first step. Let's see if the slide again wants to show up. I don't know. I think it's related to maybe to the pictures that are there. I don't know, but I don't remember that there is a picture after this. So it's kind of stuck here. This is making a lot of sense. I don't know if you just have to tell you a joke or what. I don't know. It's like a thriller here. We don't know if it is going to work or not. I'm pressing the mouse button, but I'm afraid to press it too many times, just in case that, oh yeah, okay, great, it decided. Okay, so let's go. Testing with the real robot. So in this point, where we are here today, so your code, if you have reached this point, your code has to be working on the simulator already. That's what we covered on the previous webinar. So check it out how to do it. So I presume that you have created this simulation, you have done all the tests, and then the robot works in the simulation. So it does what you are expecting the robot to do in the simulation. I know the simulation is something limited. I know it's not the same thing as the real thing, but you have to make it work on the simulation first. If it doesn't work on the on the simulation, it's not going to work on the real robot, because the real robot is even more complex than the simulation. So it's a waste of time to try to test on the real robot if it doesn't work on the simulation. In the simulation, the loop is very, very, very fast of testing. Instead of the real robot, it's a pain when it doesn't work and you don't have batteries, and it's a pain. So trust me on this. I know a lot of companies that build robots that they don't do this. They just go and test on the real robot. That's very bad. You can beat them here. You can create a product faster than them. You can create a product that is easier to maintain, and then you can beat them in that case. So do not test in the full robot and until you have it working on simulation. Then the second condition to start testing on the real robot is you don't have to test on the real robot with the whole robot built already. So if you have finished your test on the simulation and then you want to test on the real robot, you can have the minimum amount of hardware that allows you to test in the real robot. What do I mean? For example, in our case of the Barista robot, the minimum amount is just having the base that moves, then the computer over there, then the sensor over there, and that's it. Actually, we don't even need the structure or all the other things, just the cables that connect one thing to another, and that's all. That allows us to test. So don't try to make your test with the final product. We are going to reach that point today here, but not yet. We are not yet there because many problems are going to appear here when testing on the real robot. So it's a waste of time trying to do it on the real product, final product. Okay, so use as minimum as possible in your hardware. Then the things that you have to do before everything can be tested on the real robot is to identify the ROS drivers that you need to launch in your robot computer. So those are the drivers that connect to the hardware of your robot and allow to control that hardware by using ROS topics or ROS services or actions or whatever. So this also usually applies to the sensors and to the actuators. So the sensors, the laser, the Kinect, the sonar, IMU, whatever, actuators, the wheels, the joints, the grippers, whatever you have there as actuators. Then you have to test that you can access all of them through ROS. This is mandatory first, before you can test anything. So this is the basic thing that allows you to your ROS programs to access the sensors and actuators. So identify for your ROS hardware, which ROS drivers you need to launch and test it. So then create a single launch file for each one of the sensors and actuators that you have, create a single launch, and then launch each one separate and test it. Then when you have every one of those working, then you create a single launch file that starts them all. Because by doing this, you are going to save a lot of time. When you are trying to do test and rebooting, you will have to reboot the computer of the robot many times. So you don't want to waste a lot of time. You don't have to waste a lot of time launching all the launch files of the sensors, all the launch files of the actuators, once you know that is working, okay? So create a single launch file. And then you have to launch everything in the robot computer, of course, because the robot computer is the one that is connected to the sensors and actuators of the robot. Okay, so just let me answer one question here by Efson Warko. So that he's asking on the chat that, hey, isn't this supposed to be like episode 4 of the webinar? It's not, because we had some problems on the episode 3. So I'm repeating. So you're going to see we are about to reach the point that we got stuck last week. So we're about to be there. So most of the webinar is going to be new stuff. Okay, so for the Barista robot, in our case, we had the control of the wheels, basically the base that composes the Barista robot. That is a Turtlebot, is a Kabuki robot. So I have to launch this ROS launch here. That makes me control the wheel, so I can move the robot around by sending a command bell. It's a twist message of ROS. So that's very simple. Then I do this, and then I check that I can make it work. Great. So I have access to the wheels. Now, I have to access also the laser scan. In our case, it's an Hokuyo laser. Then that works with the URG node. So if I run this, ROS run URG node, then I will get access to the laser. And that's what I did. So, well, not only myself. So the team, what we did is to launch those. And once we tested that this worked, we created a single launch file. Okay, so we have that. Then we have access to the hardware of the robot. Now it's time to test our software, the software that makes the robot do whatever we want it to do. In our case, is to go to the tables and serve the coffee when somebody indicates on a touch screen. In your case, could be something, whatever. It depends on your product that you are doing. For example, if we are creating this drone that is following us, so it has to be a software that captures from the camera, identifies the person, and then creates some commands to move the robot, the drone, around the person, for example. Okay, so how do we test this? Once we have access to the hardware, we test in 3 steps. First one is with a connection PC to robot. Is the one that you can see here on this picture. In this case, the guys, Jose and now I don't remember now his name. Sorry, I forgot. I got blank on this. Okay, so the 2 guys, they are testing their software by connected through a cable to the computer, but this is not something that you have to do. That is preferably not to be done because the robot has to move. So the cable, it's a problem. Then what is more preferable is to connect through this computer on the table to the robot computer using a Wi-Fi. So this is the test with connection PC robot. Then we are going to test with the packages in the robot, and then we are going to do the final test. On the first test, let's go for the first test. Test with connection PC robot. This test means that the programs that you are going to launch are launched in the PC of the developers. So the programs, the actual programs, the navigation program, the following person program, whatever, is not executed on the computer of the robot, but in the guy's computer. Why? Because it's a lot easier, faster. In case that you have to modify something, it's a lot easier and faster. So you try this first on your computer. Everything is prepared for working with ROS, etc., etc. So that's the first type of test. Okay, so you set up your PC and robot computer on the same Wi-Fi network, of course. Then you set the PC ROS core on the robot computer. So you indicate to your PC that the ROS core is on the robot computer. How do you do that? By setting the ROS master URI pointing to the robot computer and the ROS IP, the IP of your PC. So here I have a question from Biorel that says, I know that is not the best solution, but in case I cannot use the Kabuki robot, is there some kind of USB interface in which I can put the drivers for the wheels, encoders, IMU? I don't know. I don't know what you mean exactly, but I think so. If you put the drivers, you mean on a USB, you mean like a memory stick that contains those drivers? You mean that? Or sorry, I don't understand really this question. What you mean? And Epson Warco is saying, I am thinking any microcontroller Arduino with those sensors will work as well. And yes, of course. If you have a, if you have, okay, so I am thinking any microcontroller Arduino with those sensors encoders will work as well. Yes. So Arduino, of course, if you connect the sensors to the Arduino and you make the electronics, or you buy the proper boards that directly connect to the Arduino and make those sensors, that's okay. Then you will have to put ROS on Arduino in order to control those sensors from ROS. Remember, it is possible. It did exist, ROS Arduino. So you check on the web and then you will find it. And then Viorelli say, no, the PC has USB interface. And the PC has a USB interface, and then is there some kind of USB interface in which I can put the drivers for the wheels, encoders? Okay, so I still don't understand what you mean. So maybe you can elaborate more the question. So let's move forward. So we are testing the connection of the PC with the robot. First, you put both on the same Wi-Fi. Then you set the ROS core of the PC that points to the ROS core that is on the robot computer by doing these tasks. Then you launch your ROS programs on the PC, as you were doing in the simulation. The simulation now is off, okay? Forget about the simulation. We don't need any more the simulation right now. So you are launching the programs exactly the same as you were doing for the simulation. But now what has changed? First, that the simulation is off. Second, that you have changed those variables. So ROS is made in such a way that when you do this change of the ROS master URI, okay, so when you do this, then what you execute on the PC will be actually being affecting the computer that is on the robot. Okay, so whatever you launch on your PC is going to affect the robot. So if your PC says, hey, move forward, then your robot will move forward. Okay, that's the magic of ROS. That's one of the biggest things that has achieved ROS. That's great. So, okay, so here we have some problem with the slide yet. I don't know. So what is the steps to connect, to test between a PC and a robot? So first, you do what I have said on the previous slide, all the setup here on your computer, and then you launch your program and test on the real robot. Then you see the results on the robot. Then, based on that result, maybe there will be some problem, there will be something here or there. So you modify something in the robot. Maybe it could be something as stupid as the laser is detecting some of the parts of the robot that you didn't think about. So now it's detecting some parts of itself as if there was an obstacle in front of the robot. So you had to modify the structure. Physically, you have to modify the robot structure. That happens. Or maybe something wrong in the program, that because you were using the simulation, then some variables have some values, but now that you are in the robot, those have to be some other values. Or, for example, minor changes. So I presume that those are two minor changes. So once you do the modifications on the robot, the other ones on the programs. And then if that's the case, once those modifications have been done, you have to return to launch again the programs on your PC, affecting the robot. See the result and repeat that cycle all the time. It could happen. Actually, it's very likely that it will happen. The first time that you do this, you will find out, oh, we didn't think about this, or we found that this is completely wrong in this case because of these tables, because of these people moving around, we didn't count. So then in that case, you have to do a major modification to your program then you had to go back to the simulation and do all the arrangements, all the changes in the simulation, test in the simulation, and make it work again with those changes in the simulation. And once it's working again back in the simulation, then you repeat and go live to the real robot, and then you repeat again the cycle. So basically, this slide is the one that contains the whole testing process of your ROS code with a real robot. That's optimized, okay, to go faster. Okay, great. So you will tell me, hey, yeah, but if I find errors, how do I solve them? Okay, so for that, you need to know ROS. And then, of course, I recommend you our academy to learn ROS, because we teach the basics, a specific subjects, also specific for a specific robots that you can buy and use in your products already. So you learn here how to program them, and the ins and outs, and why is this happening and why not. So I highly recommend, in case that you want to recommend here, I put here a coupon for you with a 10% discount that you can use in case you are interested. Okay, anyway, let's go for step 2. Let's imagine that you have done this test with the PC and the robot, and it's working. Now, we have reached the point where we have to test the packages, all the software in the robot itself. This means that everything is going to run inside the robot now. Okay, so how do we do that? Well, we set, again, the PC. We need, even if we are going to test on the robot, we still need the PC, okay? So this is unavoidable, because we need a shell to control everything. So you set the PC and the robot on the same Wi-Fi network. Then you use the SSH to log in from the PC into the robot's computer. So now you are inside the robot's computer. Everything that you run there is going to be run on the robot's computer, even if you are using the PC, of course. So you create a Catkin workspace in the robot computer, and then you transfer all the packages from your computer PC to that Catkin workspace inside the robot. Once you have everything there, then you launch your ROS programs in the robot in the same way as you were doing the launch in the previous step, in the step 1, PC to robot. So it's the same, but now everything is running on board the robot computer. So you have everything. And then the process is exactly the same here. The only change is that, so let me put the whole slide, because now you know everything. So is you when you are here on the first step, whatever you are doing, you are actually executing on the robot's computer. But the process is exactly the same. You launch from here, you see what the robot does, you do small modifications, either on the hardware, either on the software, and repeat. In case that you need modifications, you have to go to simulations back again. Okay. And then, so that's step number 2. Once you have this working, so, okay, so I'm launching this in the robot and everything is working, great. So now we have to go to the final test. The final test is when you put everything on the robot and it automatically starts on robot boot up. It means when you switch on the robot, then all the programs start and then the robot behaves perfectly. In this case, you cannot use a PC for nothing. Actually, you only have to use the switch on button of your robot. So for that, you have to add the main launch file. This main launch file is the file that launches all your programs on drivers. So you had to put in this main launch file the initialization of the drivers that we saw on previous slides, and also the launch of your programs, of your navigation programs. Okay, in that case, this main launch will contain, it will be the single launch file that launches everything of your programs in the Catkin workspace, if you remember from the previous slide. Then you have to use the systemctl of Linux in case that you are using a Ubuntu. Well, also I think that in other Ubuntu, even if it's not for a PC, even for Raspberry Pi, etc. You also have systemctl. I'm not sure about that, but on normal Linux, you have systemctl to execute that launch file on computer boot. It means when the computer boots, Linux goes to something that is called the systemctl. That is a system that allows you to execute things, scripts, when the robot is booting up. So during that booting up is when you have to put this main launch to be executed. And then once you have that, then if you switch on the robot, your main launch will start and then everything will start. The drivers, your programs, and the robot will make this work. So now what it remains is that you have to test again everything 100 times, as many times as possible, because even like that, even if you think that everything is working here, you will find still errors. So yeah, so that robotics are present. That's how it works. Then, so about this testing again, everything, what I recommend you is that you use very difficult real environments for testing. Like in this case, we put the robot there at the bottom of the picture there, and then we put some obstacles that were occluding almost most of the space. Of course, that's not going to be the situation, but it could be. So by doing those stress testing, you can find your product weak points, because this is something that you have to realize. Your product will have weak points. It means situations on which that robotic product is not going to work. And that's how it is. You cannot solve them all. As I mentioned on the first webinar, you have to restrict yourself to solve one kind of problems and make it work in a robust way. So it's good that you identify when your robot is not working properly. So you know the limitations, and then you can explain to the buyers. You can find rhetoric ways of explaining that make funny or even convert an error into a feature of your product, of your robotic product. But anyway, is mandatory that you learn where your robot is failing. So I have a question here that says, what is the advantage need of having ROS on Arduino? Oh, and then Epson is answering. He says, ROS doesn't actually run on the Arduino. It kind of uses it as like a slave device to a main device. That's correct. Then advantage is that your robot that runs Arduino, it's being controlled by ROS then. So you can work in your robot, in your Arduino robot, then you can run ROS programs. And there is plenty of ROS programs that make your robot do many, many things. So you don't have to build all the programs for your Arduino-based robot. That's the advantage of using ROS on Arduino. Okay, so now you have seen the part about how to test on the real robot. Basically, that's a process, and it's very funny. It's also sometimes very frustrating because it doesn't work, and finding an error on the real robot, it's a pain. It's really, sometimes it's very difficult. I recommend you that you use a lot RBIS to see what the robot is detecting, what is the current status of it. And of course, at the Robot Ignite Academy, you can see how to use RBIS for that and for many other things. You need to know, okay? I'm not getting into details because there are other courses there that teach. Okay, so now let's go. We have the robot that is moving around with all the cables, and it's doing the actual thing that we want the robot to do. So it's going and serving the coffee to the tables, or it's a drone that is following us and taking pictures of us while we are doing something, surf on the beach. I don't know. So nice, but it looks like very ugly. So we have to convert this into a real product. For that, we have to add the attrezzo. Then I already did the schematics of how to do this, but let's go a little bit more in detail. So for the attrezzo, we need to find a graphic designer that is going to design the external aspect based on the current structure of the robot that you provide to this designer. He will create an artistic vision of your robot based on, of course, on what you tell to him. So you tell, I want it like this, I want it like that, and those are the constraints. So the shape has to be like this because here there is a wheel, here there is a wing, whatever. Then you will have to find a 3D modeler. And this 3D modeler is the one that converts the graphic design that the designer has created into a file that can be printable in 3D with a 3D printer. And that's how we are going to build our cover for our product. And then you will have to find a 3D printer where to print the covers of your product. And finally, once we have the covers and everything on place that make the robot look more like a product, then we have to do some extra details if possible, because they make them look more like warm to people. And we'll see which ones, for example. So for finding a graphic designer, I have put here a link that you can use for a list of possible. This is one solution that I'm proposing, but there are many. So if you know some graphic designer, you can talk to him. If you don't, this is very convenient because it's something that you can do from anywhere of the world. It's an online system. So let's go. I'm going to click here. And so I presume that okay, yes. So it's on Fiverr here, and here on this page you have plenty of graphic designers. Some of them, they are specialized in products. Some of them are more specialized in other type of designs. So you can check the work of all of them and see that the prices are quite nice. So you have many here, and I use this a lot for services like this that are just for a moment. So you have the link here. Yes, in this place here, and you can use it if in case that you want, if you don't know how to find a graphic designer. Okay, so in that case, is that what we did for designing the graphic aspect of our robot, for the Barista robot. And that was the graphic conceptualization that the graphic designer created. Okay, so yeah, they used to think about, the graphic designers, they think about the future, and they would like to make look like a very super nice, but that's not possible, physically possible. But they, of course, they try to make it like in the movies then. But that's great because this is the first step. And then when you have the graphic design, then you have to move into a 3D printable file. And here is where you need a 3D modeler. That is the one that is going to convert the graphic design here into a 3D version that is actually real. So this contains the actual measures of the robot and the spots where the laser is going to get out, the points where with the exact size for the cups, the points here where we are going to put the screws and attach one part to another. Okay, so this is the translation from this. Okay, from here into the actual thing that we are going to print. Again, if you don't know where to find a 3D modeler, I have put here another link that links to the same Fiverr, but with a different search. Is for 3D modelers. You can find a lot there, and check the one that you like the more. So once you have this, then okay, yes, I put this special comment here that you have to have a direct connection to that modeler, because otherwise he can make mistakes in the design based on the distances. Take into account that you are doing this online, so this guy is not seeing your actual product. So it depends on the information that you are providing to him. So check everything twice, talk to them a lot, so that they do this 3D drawing correctly. Okay. Then the next thing is to find a 3D printer and print it out. And here, this is the best place I have found by difference, 3D hubs. So if you go to this web, you will see this is an international website, but you can find the local 3D printers that are around you. So even if it's international, it is connected to your local printer. So you can check here the one that provides you the best service, the best price, whatever is your criteria, and that is near you. So you don't have to wait for whatever weeks until they send that to you. In our case, we send it to a printer here in Barcelona, in Spain, and they did it from, I don't remember, but they did it quite fast, like in less than a week, like 5 days or something. Here I visited them just to check that everything was working okay. And so that was some part of the process of printing it. So, and then I use this to find them. I use these 3D hubs, okay? And also it's very, very professional, because you can ask the people for different offers based on different prices. And well, just check it out. I have to say that I have no connection at all with 3D hubs, and so I'm not getting any commission or whatever. So just telling you because I was so amazed of the service. That's it. Only it's just the opposite that I am with this slideshow system. I'm not so amazed with this. So I'm a little bit pissed off. But anyway, here we are. So that's the result when we print it, and then we add some extra details. In our case, we add stickers that reflect whatever we want to reflect on the product. For example, we created some stickers for the coffee shop where we were going to do the demonstration. And then here you have a place where they create very nice stickers, and they can send it to you from whatever the place. Also, it's international, and they have different types of stickers. These are just a few. Check it out here, and you will find many different types of stickers that you can create for your product. And then finally, you can add stickers and also some physical details. In our case, what we add was what is the word in English? It's a bow tie. Yeah. So because that was in the original concept of the artist, the artist that we contract for doing the 3D drawing, 3D design. So she decided to add a bow tie, and then we found that it was very, very nice, good idea. So we included those physical details. Remember to add any other. If you don't know, ask the artists. They are so great for finding this. We are engineers, and sometimes it's difficult for us to find that. But listen to them, because they have very good ideas in case that you cannot find. Okay, great. So final product, as you already have seen, is like this. Is with the 3D printed covers, with the stickers, with the bow tie, and everything running. All the software on board the robot. So we don't have to control anything from the outside. Then, once you have this, we go to the final part, that is the part of the official presentation. It means you have finished your product. Now you have to get your product known into the world, So, and start getting clients. So let's see how. First, let me see that there is here a question by Daman. Says, I assume there is already code available to establish communication with Arduino or other microcontrollers, right? Yes, it's already with Arduino, not other microcontrollers that I am aware. With Arduino, you can find them on the ROS page. So if you visit ros.org, or basically you search ROS Arduino, then that's it. And some guy with an Arabic name that I cannot read, I'm sorry. He says, we can use ROS to reconfigure the 3D printer. Yeah, possibly yes. It depends on the printer. If it is ROS compatible, then you can, of course. So let's go for the official presentation. Some tips that we learn from our presentation of Barista the robot. So then again, I have some problems here with the, okay, here it goes. So what are the steps for preparing the official presentation? First one, you have to select the event location. So is the place where you are going to do the official presentation. Remember that we are talking about a physical product. So your presentation has to be physical. I mean, we are going to build other things like electronic stuff, but you have to provide something physical to relate later and to build trustability. So you need to do a physical presentation demonstration of your product. So first step, select the event location. Then you have to prepare a demo of your product for that location. So it has to demonstrate whatever you want to show that your robot is capable of. In our case, it was capable to serve the drinks to the tables. So you have to prepare that demo, how it's going to be. We are going to start here. So we are going to show the people how the person creates the coffee, then how it presses the touch screen, so indicating the robot that has to go to the table, and then the robot will move until the table will have some person there that is a prepared person. It's better that is a prepared person, so that it knows what to do, then grab the drink, and then the robot will return back. So for example, so you have to prepare this demo, and it has to be very well prepared and robust. It means that it has to work. So if you find that things are getting into the date of the demo and doesn't work for whatever the reason, something goes wrong, then decrease the level of the demo. I mean, just show whatever it works, but whatever it works, it has to work. So you have to be sure that it's going to work. Okay, so that means easy but robust. Then you create a web page of the event. This has to be in parallel with the preparation of the demo. In this web page event, you are going to start making promotion of your robot and especially of your event, so people can relate to your event. So create a web page of the event. Let me show you the one that we created here, and that I'm going to put here the sound so you can check it. That is working because we created this web page for the Barista presentation. So it contains here a kind of video that we are going to see that, but then we indicated the release conference and demonstration these days in Barcelona. Here is the story of how we created. But as you can see, we are indicating things about first robot serving coffee, and we see coffee things around. We indicate simulations, but we don't show the final product all the time. So as you can see, we are creating a kind of curiosity about what is this, how is going to be. We see some captures, some people with the computers, what are they doing. So you provide all the details, where is going to be the schedule. You can check this for example as a template for your own event. And then we added this mailing list for start collecting emails of people that is interested on this. And this is very interesting to have it, because then if people leave their email here, then it means that they are interested on your product. So you can contact them afterwards. So basically that's the web page. Okay, so you got this web page. Also, you had to create a promotional video that's very attractive for people. And it's very likely that it will convert into something that people shares. And that's what you want. Let me show you ours. And let me put some volume here. And we cannot see the volume. In this case, So let me see. Yes. So in this case, in this video, as I mentioned before, we are not showing the robot, but introducing what it's about. And we create all the feeling about this. How to create this video? You can use the same Fiverr for building the video, for finding somebody that will help you to build this video. Actually, this was built by one single lady that is a friend, and she's very, very good. She's starting on this subject. Then we don't, yeah, so we don't show at any point in time the robot, the whole robot, but we show the perspective that it's getting from the robot, so the people can feel, wow, I would like to see this moving around the shop and doing this in the demo. So you have to create kind of a feeling of wanting to come. Okay, so that's what we tried with this video. But also here, you just have to be creative. Ask the artist. She knows a lot. So basically that's it. And then, well, that's an example that you can check, okay? So have a look. Finally, we are about to finish. It's very finishing. And let's see if this starts properly. Okay, official presentation here, event, then promotional video, then distribute this among peers, friends, and family and social nets. You want your friends and family to support you on the presentation. You need to convince them to come, even if they are not interested on the product, but you need to show that a lot of people is going there. Okay, apart from the, of course, you have to approach the real target, the people who can be your client or in robotics, etc. But also make presence with your friends and family. Then finally, you have to contact the press, local and countrywide, if you can, if you know how to do this. This depends many on the country where you are. And my advice is that you do not expect much from them, because the press is very, very passive. They don't want to work very much. They are not hard workers at all. So I have prepared a special slide for dealing with the press that maybe could save you some work or be helpful for you. So I want to, if you want the press to attend the event, take into consideration this, that the event has to be in the morning. It looks like they only work in the morning. So if you schedule in the afternoons, they don't want to go to the events. So yeah, they're like this. So what can I say? Also schedule the event on Tuesday, Wednesday, or Thursday. Yeah, because Monday from the weekend and very tired, and Friday, the weekend is about to start, very tired. So that's it. And then that's it. Then also you have to prepare something to eat or drink for free. Otherwise, they are not going to come. Yes, that's exactly how they work. I'm sorry, that's a fact. It's not an opinion. Okay. So then you have to create a press release ready to send, so that you have to create a press release that whoever tells you, hey, do you have any information? You have to have this ready to, yes, with everything that they are going to need. They don't want to write. They don't want to prepare. They don't want to work. So you have to provide this, everything done by yourself. I'm sorry. I know you are roboticists. You are not on this, but that's what it takes if you want to do a successful event. And here I have put a link that contains some press release templates. It's very good from HubSpot. So check it out. Then also prepare a web page for the press. This web page, I have put here an example also of HubSpot because it's very good. The web page of the press is it's a page that contains many things that they may want to use for their news, for their writings about your robot. So you had to make them very easy for them to use your things. So you had to provide your logo, you had to provide pictures of your robot, you had to provide content about your robot, why is this, how it works, etc., etc. Have a look at this link and you will see an example of how to do this. And you can organize exactly like this. So I have to tell you that in our case, we didn't do those two things. Actually, we didn't do, we only did this one, schedule. I think that's the only one that we did in our case. And that's how we learn afterwards all those points here that I am explaining to you. So I have here some questions. Then Viral is asking, maybe I overreact, but the robot has an emergency button. Well, it depends on the robot. Of course, if your robot can do something bad, then you have to have an emergency button. In our case, our robot is very simple. If it crashes against somebody, it's going to do nothing, not even a child or a pet, because it moves very slow and has no power. But if your robot can harm somebody, then you have to have an emergency button. Yes. Then via George, another question. Ricardo, thanks also for the social advices. We deal with robot, not humans. Yes. Yes, that's right. Yes. Okay. So for the official presentation day, get your team ready in the back. Technical video photo recorder. So in our case here, we have Alberto and Miguel that are part of the team, and they haven't been involved in the creation of Barista, but they came for the event and had their computers ready just in case that something went wrong. Very quickly, they can solve the problem so the demo doesn't suffer. So they were ready. Our demonstration was completely real, no fakes, everything was working. Okay, be prepared a lot, but we were prepared in case. So you had to do this, okay? Then you have to start the presentation on time. Start on time, because otherwise it's going to be a nightmare. The ones that are there are going to get nervous. Then you didn't know why to wait for this and not wait for the others, etc., etc. And then maybe you are waiting there for somebody that is not going to come. So just start in time. On the presentation, do a short explanation, just a very short explanation, 5 to 10 minutes. In our case, we three were involved in the development of the robot, and we spoke, each one of us, some minutes. Each one in charge of the part that was in charge. Then you go straight to the demo. That's the important thing. That's what everybody wants to see, the robot moving around. So go straight to the demo. And then maybe you will have to repeat the demo many times because people want to see again and again. That's very fun. That's very interesting, and is very rewarding for us because we see that our work is being accepted and liked. Then you can have a time of questions and answers. In this case, it was the press that was interviewing Jose, and well, they were, and also Salva. Oh, come on, I couldn't get his name. Sorry, Salva. You are a crack. You are super great, and I couldn't remember your name. I'm sorry. I apologize for that. Well, so Jose and Salva, they were answering the questions. And of course, remember to take a lot of pictures and videos, because this is going to be very useful material for the rest of the products, for the rest of promotions that you are going to take. So don't forget that. As I said on the first point, you have to have a video photo recorder person that is dedicated only for that, on that event. So don't forget that. Don't try to do it yourself, because you have to be on other things. Get somebody to help you, your brother, your friend, whatever, but somebody else that takes lots of videos and lots of pictures. And basically, that's it. That's it for the third webinar. And then on the part 4, your homework, in case that you are building your own product based on this webinar series, So here is your work. You have to do your tests on the real robot and let me know how it goes. So test on the real robot, then send me your designs whenever you have a design, in case that you want me to check it or have a give you my comment, my opinion on your designs, and then try to print it out. So then you have to do first, the homework is test on the real robot, make the robot work, and then start building the product part of your robot. So get a designer, make him to develop your design, and then let me know what is this about. And then once you have this, maybe we can discuss about the third part, that is creating the event. But first you have to solve those 2 points, okay? So I have received the work of some of you that are listening to the webinar, and already some of you are already been advanced, so you have done even the test on the real robot, and I can see the videos that you have sent me. I'm asking for permission. I send you an email for permission to publish this, so I can retweet and put it, publish somewhere there, somebody else can see how this process works, and somebody is trying to make a product based on this process. So that's it. Just remember that we have the ROS Developers Conference. That is an online event on July. So you can attend without moving from home. And it's 2 days in a very interesting time zone for everyone, because it's on weekend. So you can attend for sure. And you are going to follow the practicing at the same time as the speakers are teaching you about ROS. So we are inviting a lot of top developers of ROS. They are going to teach us how to do things interesting, like controlling humanoid robots, like how to teach to undergraduates robotics using ROS, how to build a system that localizes inside and outside of building, etc. So they are going to teach us how to do it, and we are going to do that on real time, all the attendants. So I highly recommend you this. Well, nothing more. I'm here for some minutes more in case that you want to have answered some questions. In case that you don't, thank you very much for attending the webinar, and I hope that this has been useful. I hope, please, if you like it, subscribe to our channel, press the bell to be notified, and give us a thumbs up. That helps us a lot. Also, in the meantime that I'm waiting for the question, let me put another thing on the air, so maybe you can answer me about this. So I was thinking about creating a series of products that we follow. So we follow all together the creation of those products following this methodology. So the idea is that we create together those products, and we see how it evolves, how those products are created step by step until we reach the presentation mode. So the idea, for example, for creating products, you can suggest me one. I suggested two. In that case, one was that drone that is flying around us and following us and taking pictures of us or videos of us. Yes, I know that there are others that exist, but that would be our product. Another thing could be, for example, the robot that goes outdoor and goes from one street to another, sending some mail or some package or whatever, and it goes by itself. So it takes into account the crossroads, it takes into account the traffic lights, and then it reaches the door with some limitations, of course. So you can suggest me others, so we can try to do it together. You know, so the idea is that we do these webinars every Tuesdays, and we go. I will show you how we have done for creating that product on the step number 1, step number 2, and step number 3. So here is a question from the man that says, what are the next steps for the Barista project? Is there a market? Yes, so the next step is to start selling. You have to start selling. That's another part that is nothing related to robotics, but is related to companies, to building a business. And our case, we are selling this product, but we are not doing an active sell. So because we have many things on board, we cannot dedicate to that. But it's a product that is on sale and that is running in Barcelona here in a coffee shop, so you can go and watch it. And then that's another matter that so we are not dedicating the time for that, but it's something that has to be done. In your case, if that is your product, you will be in charge of doing this. And for that, there are many techniques that I can explain you, because I'm applying this to the construct company. So, but it's not the place to do this. If you come to Barcelona, we go to have a coffee and then we can talk about this. You are invited to contact me when you come to Barcelona. Any other question? So please tell me on the comments which kind of products you would like to have built, so we can build them together here online in real time, and then we can see the process of how to build that product. Also, we'll talk to the companies that can provide us the hardware, so maybe we can get a better deal for this kind of product. And I don't know, let me know. So if you don't have any questions, I'm waiting a couple of minutes more, and I don't know what to explain you. That well, yes, tomorrow we have another live class that is a class for learning how to use industrial robots with ROS. So if you are interested in this, you can attend the class. You will be practicing with me. It's not passive listening like this webinar, but it's going to be active learning. You are going to practice at the same time as me, with me, sorry. So I'm also going to provide you with the packages of software that we are going to use, and it's going to be very interactive and entertaining. So thank you very much. Yeah, I see that people is saying about the male robot. Yes, please write it down into the comments, because otherwise nobody can talk about it, because this chat is going to be stopped once we finish the webinar. So if you can make me the favor to put it into the comments of the video afterwards, after we finish, then people can also vote and we can create a chat, a dialogue. Viral is asking, can be used for industrial ROS? Yes, ROS can be, I presume that you mean industrial robots. ROS can be used for industrial robots, and there is a special packages that are called ROS Industrial. And especially tomorrow, we are going to see on the live class. It's a live class about learning ROS, okay? So it's a live class that if you come, you will see how to use ROS with an industrial robot, and you will be doing. So you will not be listening to what I explain, but you will be doing. Okay, guys, so I have to leave already. Many other things. It's a pleasure always to be here with you, and keep an eye, because I'm going to move this about creating other products and creating those webinars for following the creation of other products. So thank you very much, everyone. Thank you, and see you another time. Bye.